Well, hello and welcome back, mathematicians. We are discussing today about dividing decimals by decimals. And we said that there were several ways to do this, and there are more even than what we said in class, but we discussed 3 specific ways to do it in class. And so method number 1 was to draw a picture wherever we could. So in this case, we have a dividend of 8/10, and we're dividing it by 2/10. And whenever we have a divisor, we have a question that we like to ask ourselves, which is how many, in this case, 2/10 are in 8/10. And you see on the number line in front of you are 8/10. And so there's 1 2/10, 2 2/10, 3 2/10, and 4 2/10 in 8/10. All right, so our answer to this is 4, and you can see this because we have used method 1, which is draw a picture. Well, we also have a method 2, and method 2 is to use what we know about fractions. So in that case, we start out with 8/10 divided by 2/10. And we said, listen, we can rewrite these as fractions. 8/10 divided by 2/10. Now, there was something special that we learned about dividing fractions, and that is that when we divide fractions, we're actually able to multiply by the reciprocal. And the reciprocal, as you'll remember, is that special number that when I multiply by it, I get 1, right? In this case, 20/20, which is 1. All right. So we're using inverse operations, which is multiplication with an inverse number, which is, in this case, 10 halves. All right. So we're going to rewrite this as 8/10 times, that's our inverse operation, 10 halves. All right. And we're able to simplify this right off the bat, but I'm not going to right now. I'm going to go ahead and let it stand. I multiply across numerator with numerator, denominator with denominator, and I get 80/20. Okay? And then at this point, I can simplify, or I can just divide. I know that 20 goes into 80 4 times. Okay? That's a very simple one to say, although I could have simplified it if I wanted to. And if I wanted to, I would have done it this way. 10 goes into itself once, and I simplify across. And then I do the same thing over here. 2 goes into itself once, and it goes into 8 4 times. And so then I can say 4 times 1 is 4, and 1 times 1 is 1. So my answer is 4, as I saw before. All right. Now, there's also a method 3. And method 3 involves this. Okay, we call it making the divisor a whole number. And this is going to look this way. We start off with this division problem. 8/10 divided by 2/10. And this is a little complicated, and we don't really want to do a problem like this. So we're going to multiply this by 1, and when we multiply it by 1, we will not change the value of it. All right, so we're going to multiply by 1 in the form of 10/10. And you know, if you have 10 of 10 pieces, you have 1 whole, right? So we multiply across, as we always do when we multiply fractions, and we get 8/10 times 10 is 8, and 2/10 times 10 is 2, and 8/2, or 8 divided by 2, is the same as 4. So this is 3 ways that we learned to divide by decimals. All right, and now we're going to put those into practice. We have here hundredths. We're dividing hundredths. And you see that when you're doing this with method 1, the drawing gets a little scary, right? So we couldn't really, on this screen, have a number line as big as we need. So we've got 1 4/10 and another 4/10 and another 4/10. Well, we're up to 12 tenths, but 56 hundredths is way over here. And these were 1 400th, 2 400ths, 3 400ths, 56 hundredths, way over here. And maybe we don't have enough space on our number line for that. So let's just skip right to method 2. And that was to use fractions. So we have 56 100ths. Now, notice that it's not 56 tenths. We have a 5 in the tenths and a 6 in the hundredths place. So we've got to put this decimal over 100. So we have 56 100ths divided by, there's a 0 in the tenths spot right here, and there's a 4 in the hundredths. So this is divided by 4 100ths. And as we know, when we divide fractions like this, we like to multiply by the reciprocal using an inverse operation with an inverse fraction. So we keep the first one, 56 100ths, and now we're going to do the opposite of division, which is multiplication, and do the opposite of 4 100ths and call it 100 fourths. So at this point, we could multiply across, but there is a lot we can simplify here. And right off the bat, we see we have 100 just across from each other. So it goes into itself one time, and we can multiply across. 56 times 1 is 56, and 1 times 4 is 4. Okay, and now we divide, and we find that this is 14. All right. That's method 2. What about method 3? And method 3 is in method 3, we're going to make the divisor a whole number. So here we have our division problem, which is 56 100ths divided by 4 100ths. Okay, so because we want to make this divisor a whole number, we're going to multiply by 100. But if we multiply just by 100 on the denominator, we change the value of the fraction. So we're going to multiply this fraction by 1 in the form of 100 100ths. This is actually 1. The value of this is just 1, all right? In the form of 100 100ths. And when we do that, we're going to get 56 fourths. And then we can do our division problem and come up with 14. All right. So what actually is going on here? Well, the first thing you're doing when you make a fraction like this is simply expressing this division problem in a fraction. And we know that every division problem is a fraction, and in fact, the division symbol is a fraction. And so when we're going to multiply that by 1 in the form of 100 over 100. And when you multiply a number by 100, you actually are moving the decimal point 2 places to the right. So you see you start here and you hop it over 2 spots, right? This is every time you move a decimal place 1 time, it's a factor of 10. So when it's 100, you're going to do it twice. And then, of course, you work it down to 14. Now, if you look at this in the traditional division, what you're doing is moving from this problem over to this problem, which is just a little easier to handle. And if you were to go ahead and do long division in this case, you know that 4 goes into 5 tens. There's one group of 4 tens in 5 tens. Or we can say 10 here times 4, which is 40. And when we subtract it, that leaves us with 16. And we know that 4 goes into 16 4 times, right? So that is how it works. We just maintain the same relationship between the numbers. but we use them in a different place value. All right. So now we're going to go on and we're just going to practice this. We have several problems here from this point on just for practice. And we're going to start off with this one. But before we do, we're going to estimate to predict, right? So I want you to think about these numbers in front of you. The division problem that we're looking at in front of us, there's a relationship between these numbers, okay? And anytime you see something close to a 75 and a 3, you should immediately think that 3 times 25 is 75. Oops. All right. And this is not quite 75. It's actually 3 away from 75. So I'm going to tell you that I believe that this answer is going to be about 24. Okay? Logically, in my mind, I think 24 would be a very good estimate here. But if you estimated 25, I wouldn't quibble with you. All right? So let's just say this is my estimate, and I'm estimating to predict so that I will know whether or not my answer is reasonable. All right? So method 1 is to take these numbers and turn them into fractions. So 72 100ths looks like this. And we're dividing it by 3 100ths. And of course, when you divide by a fraction, multiplying by the reciprocal makes it easier to process here. We're going to turn that division sign into an inverse operation of multiplication, and therefore we are going to be inverting also the fraction. Okay, at this point we can go ahead and simplify those 100s. They go into each other or into themselves once each, right? And then we multiply, we get 72 divided by 3. And if I think about it, logically, I can break this apart, right? I can break this into, let's see, 60 and 12. And I know that there are, let's see, 3 goes into 60 20 times. 20 times 3. And this one is 12 times, 12 is 3 or 4 times 3. Okay, so that means that this is 24. And I was correct. My estimation was spot on. All right. So now we're going to try method 2. And method 2, of course, is that we need to make the denominator or the divisor into a whole number. So our division problem is 72 100ths divided by 3 100ths. Don't forget the 0 when you copy down your problem. We're going to multiply this by 100 over 100. Because we want to move that decimal point. And we learned that when we have a decimal like this, and when we multiply by 100, we're actually moving the decimal point 2 places to the right. So 72 100ths becomes 72, and 3 100ths becomes 3. And so then we've already done this division problem, but I could do it a different way for you. 72 divided by 3 looks like this. So if I put a 2 here in the tens place, 20 times 3 is 60. And when I subtract, I'm left with 12, and that's 24. So my answer is 24 times. Right? And of course, again, it's reasonable. Make sure that you're making the divisor a whole number.